Hello friends, welcome to the part 2 of water analysis. The factor conductivity is the important factor. Here electrical conductivity is measured for analysis of the water. For that conductometer instrument is used. The cell of the conductivity meter or the salt bridge is filled with the water sample and the electrical conductivity is measured. The expression of that measurement is the decisiemens, here that is what the decisiemens per meter at 25 degrees Celsius, which is numerically equal to millimole per centimeter at 25 degree. Sometimes the unit of expression is millisiemens, that is ms, ds means decisiemens, ms means millisiemens per centimeter, which is numerically equal to the micromole per centimeter. Okay. Now, the soluble salt present in the water that dissociate into their respective cations and anions. That means, when the salts are soluble in the water, what happens? They undergo dissociation, and whenever the salt are dissociate, they gives cations and anions. And because of that reason, these cations and anions carry some current and impart the conductivity. Why water is conductive in nature? That is the reason why water is conductive in nature. The reason is because of that dissolved salt present in the water, they undergo dissociation and produce some ions, cations and anions, and those cations and anions carry the current, and hence water becomes conductive in the nature. Higher the concentration of the ions, greater electrical conductance. Okay. The amount of the salt present in the water is higher, dissociation is higher, the number of ions produced is higher, then electrical conductance is higher, and vice versa. Okay, less the resistance of the electrical current. Okay, if conductance is higher, then resistance is lower. Why? Because C is equal to 1 upon R, conductance is equal to reciprocal of the resistance. So, if conductivity is higher, resistance is lower or smaller. That means, as the amount of ions dissociate in water is higher, conductivity higher, resistance smaller. Thus, the measurement of the electrical conductivity is directly proportional or directly related to the soluble salt concentration. Conductance is the reciprocal of the resistance involved, and the unit of measurement of the conductance is reciprocal of the ohm. Okay, because the unit of resistance is ohm, 1 upon ohm is called mho, MHO. That is why the unit of conductance is the mho, designated as mho or Siemens. When electrical conductivity, what is the electrical definition of the electrical conductivity here? When electrical conductivity is measured between the electrodes. Okay, conductance is the reciprocal of the resistance. What is electrical conductivity? It is the conductivity measured between the electrodes, cathode and anode, having a surface area of 1 centimeter square, and the distance between these two electrodes is 1 centimeter. Okay, that is called electrical conductivity, and the unit of that is Siemens per centimeter, as I told you in the starting of the lecture. That is Siemens, decisiemens, millisiemens, Siemens per centimeter, etc. Electrical conductivity is directly, look at here, electrical conductivity is directly proportional to, that is the surface area, small a is called the surface area, and inversely A by L means inversely proportional to the length. L is the length or distance between the two electrodes. So, we can say that EC is equal to K into A by L. A is area, L is a length, K is a proportionality constant known as the specific conductance. That is the important MCQ in case of A is equal to 1 square centimeter. When the value of A is equal to 1 square centimeter, L is equal to 1 centimeter, that means it is 1 by 1. The answer is 1. Electrical conductivity equal to specific conductance. That is important MCQ. Then the measurement of the electrical conductivity, it is the practical, the measurement of the electrical conductivity here. Okay, the instrument consists of an AC salt bridge or electrical resistance bridge and conductivity cell having electrodes coated with the platinum black. Okay, that is the instrumental setup. The instrument is also available in a calibrated assembly, that is for giving the conductivity of the solution in millimos per centimeter or decisiemens per meter at 25 degrees Celsius. What is the principle of the method? Okay, the principle of the method is here a sample Wheatstone bridge circuit, the content is removed from here. So, you please note down the content. A simple Wheatstone bridge circuit is used to measure the electrical conductance by null method. The bridge consists of two known and fixed resistance R1 and R2. So, here that is the two known and fixed resistance, that is R1 and R2. Standard resistance R4 and the unknown R3. Now, here the blank, it is the variable resistance R4 is adjusted until a minimum or zero current flow through the AC galvanometer. So, here total 4 resistance are there, R1, R2, R3 and R4. From that, R1 and R2 are fixed and known, that means the value of those resistance R1 and R2 are known and they are fixed throughout the practical. 2, R3 and R4 are variables in which they are standard resistance. R3 and R4 are standard resistance in which R4 is standard and R3 is unknown. That means the value of resistance we want to measure out, that is unknown R3. So, R1, R2 variable that is fixed and known values, R4 is a standard, R3 is the unknown value. Now, in principle what happened, the standard, that means R4 is adjusted in such a way that your galvanometer, the reading in the galvanometer is shown 0. So, here that is the ratio R1 by R2 is equal to R3 by R4. I want to find out the value of this unknown R3. Okay, I want to find out this value R3. So, make him subject, R3 is equal to R1 by R2 into R4. These two values are fixed and known, you know already the value, and that is the value R4 that is from the instrument. Okay. When you adjust the resistance R4 in such a way that the AC galvanometer shows the reading 0, that resistance put the value here. Okay, in that way you can find out the value of resistance of the unknown. That is the equipment and the reagent, conductivity meter and cell. I already told you that conductivity meter or conductometer is used. Some beakers are there. Standard potassium chloride solution 0.01 molar KCl solution is must be there to calibrate the conductivity meter. That is the method by which you can prepare the standard KCl solution. Why we prepare this solution? Because it is a strong electrolyte. It is 100% dissociate into ions, cations and anions. And because of that reason, it gives you the value of reference conductivity, electrical conductivity. The value is from the literature data, that is 1.413 for 0.01 molar KCl solution. That is the method. 9 to 5 ml beaker, in that is 1000 ml beaker, take the water sample, warm up the instrument for 20 minutes, use 0.01 molar KCl solution to calibrate it. I already told you that the solution is used to calibrate the instrument. Rinse the conductivity cell which distill with distilled water and then with the sample. Now, temperature and cell constant correction are adjusted on the conductivity meter. Then connect the conductivity cell to meter and dip in the sample. Then that is conductivity cell connected to the instrument, put that conductivity cell into the sample solution and read the reading, read the conductivity value in the decisiemens per meter. That is the easiest way. With the help of the instrument, you can find out the conductivity of any water sample. Then acidity. Okay, why water become acidic in nature? It is due to the presence of uncombined carbon dioxide, salt of strong acid, weak base and mineral acids. Okay, and it is titrated with the standard solution of strong base. It is a simple acid base titration. Because your water is in acidic in nature, then titrate your water sample with the strong base with the help of a suitable indicator like phenolphthalein. Okay, the method is, you know that approaches the conical flask, you need conical flask for acid base titration, pipette you need burette. Okay, phenolphthalein and methyl orange are indicators here, that is 0.01 normal NaOH solution is here. You know how to prepare the solution, 100 ml sample in a conical flask. That is the method, that 100 ml sample solution is take in a conical flask, 2 drops of the indicators are added and titrate it with the that is 1 by 100 0.01 normal NaOH solution, that is filled in the burette, drop by drop addition. Okay, you know that color change of the method is the from colorless to pink endpoint. Note down the value in a burette reading, that is the normality. N is equal to normality of the NaOH solution, that is used volume of NaOH, then normality 100 into 1000 divided by volume of the sample taken, that is the burette reading. Okay, put the values here, you can find out the normality. Okay, then alkalinity, that is the opposite of the acidity. Okay, why water becomes alkaline in nature? That is due to the presence of the salt of weak acid, strong base. The main are carbonates CO3 minus 2, bicarbonates HCO3 minus, hydroxide OH minus. Alkalinity can easily be determined by titration using the phenolphthalein, that is also a acid based titration, but here the most important thing is the alkaline pH range must be above 8.2. Those are some reagents: phenolphthalein indicator, methyl orange indicators, standard sulfuric acid. Here we use 0.02 normal standard sulfuric acid as a titrant, that is filled in the burette. That is the method, you know, that is in a porcelain dish, 5 ml of the sample containing not more than 1 milli equivalent of the carbonate plus bicarbonate is diluted with the distilled water to about 25 ml. Pink color is produced here with the few drops of phenolphthalein indicator. That means in a evaporating dish, when you take the 5 ml of the water sample and dilute to 25 ml with the distilled water, if you add 2 to 3 drops of the phenolphthalein, the color of that water sample becomes pink because of the presence of carbonate and bicarbonate. Then titrate the solution with the 0.02 normal sulfuric acid until the color just disappear. Okay, because of the alkali carbonate CO3 minus 2 being converted to bicarbonate. This is called burette reading A. Okay, here when you add sulfuric acid from the burette into that evaporating dish, the pink color is removed. Now, the removal of pink color is indicate that all carbonate CO3 minus 2 present in the water is now neutralized. Now, there is no CO3 minus 2 present in the water. That burette reading is not down as capital AML. Okay, remember this. Then, after the solution becomes colorless, add methyl orange in the same 1 to 2 drops of the methyl orange and continue the practical, continue the addition of that sulfuric acid, okay, till the color change is yellow to rose red. When you add methyl orange, the color of that evaporating dish, the solution in that evaporating dish becomes yellow. Then you continue the addition of the sulfuric acid from the burette, the end point is yellow to rose red color. That is called B. It is not down as capital B. That is indicating the presence of HCO3 minus bicarbonate in the solution. So, here A is called acid used for titration with phenolphthalein indicator, B is called acid used for total titration, that is phenolphthalein as well as methyl orange both. So, first of all, those are the formulas by which you can find out the value. Okay. Here when A is equal to B, that means when the both readings are same, the alkalinity is find out with the help of this equation. You have to memorize this equation. When A is greater than 1 by 2B, okay, this can be find out with the help of your reading. Okay. If A is equal to 25 ml, B is also equal to 25 ml, then A is equal to B. So, the alkalinity it find out with the help of this equation. If A is equal to 25 and B is equal to 12.5, okay, that is A is greater than 1/2 of B. 1/2 of B, that means if B is equal to 25 ml, 1/2 is equal to 12.5 ml. That means A is greater than 1/2 of B. In that case, this equation is utilized to find out the alkalinity. If A is equal to 1 by 2B, that means A is equal to 12.5, B is equal to 25, then 1/2 of 25 is 12.5. So, in that case, when A is equal to 1/2 B, this equation is utilized to find out the alkalinity, and similarly, when A is less than 1/2 B, this equation is utilized. When A is equal to 0, that is because of the alkalinity of bicarbonate, this equation is utilized. So, by using all these formulas and those conditions, you can easily find out the alkalinity present in the water. So, for that reason you have to memorize all these formulas with the conditions. Okay. Those are the long questions. Next point, that is called hardness of the water. Okay, you know what is hardness. Two type of hardness are there, temporary hardness as well as the permanent hardness. The temporary hardness is due to the presence of bicarbonate salt of the calcium and magnesium, and it is easily removed by boiling of the water. But the permanent hardness cannot be removed by boiling of the water, and it is due to the sulphate, the chlorides of magnesium and calcium. Okay, the sulphate and chloride salt of magnesium and calcium give permanent hardness. The permanent hardness due to the salt of calcium, magnesium, strontium, iron and the manganese. Those are some cations and anions which are responsible for hardness of the water. You have to remember those cations and anions, that is for MCQ purpose. That is the method. Iriochrome black tea indicator is used, that is the process by which you can prepare the solution of the EBT, that is the indicator, Iriochrome black tea. Ammonia buffer is utilized here, and standard EDTA solution is here. EDTA is the primary standard, that is filled in the burette. It is your titrant. Now, what is the method here? 100 ml of the sample solution is taken in a conical flask. I already discussed that topic of titration in the complexometric topic. 100 ml sample in a conical flask and then add 1 ml ammonia buffer and 2 drops the Iriochrome black tea indicator. That means in a conical flask, water sample is 100 ml, 1 ml buffer is added and 2 drops of the indicator is added. Then titrate the solution with EDTA solution, that is in a burette, drop by drop addition, until the color change is from wine red to blue or bluish green. Note down the reading, that is your end point, and then put the values here, the volume of EDTA, that is burette reading into normality into 1000 by ml of sample taken. By this way you can find out the hardness of the water. Then the chlorides content. Okay, chloride is invariably present in the small amount in almost all natural water. All water contains the small amount of the chlorides and its content goes up appreciably with increasing salinity. As the salinity of the water increase, the amount of chloride is also increase. Some of the method like Moore's method is used to find out the chloride content in the water. And for the public health, the content of the chloride in the water must be 250 milligram per liter. It is not harmful, but increase of the chloride beyond this limit, beyond 250 milligram per liter, that is the limit of maximum chloride content present in the water. If it is higher than that, then it is harmful for the application or the indication of the organic pollution. The method is there. Reagent are used for this is 0.02 normal sodium chloride, 0.02 normal silver nitrate, and the potassium chromate indicator, that is K2CrO4 indicator is used. This is the method by which you can prepare the solution. Method is there. 5 ml of the water sample is take in a porcelain dish, that is evaporating dish, and dilute it to 25 ml with the distilled water. Then add 5 to 6 dot of the indicator and titrate that with the AgNO3 silver nitrate solution. Okay, brick red color tinge is appears and not down the volume. That is the end point, brick red. That is a simple titration. Put the values here. Normality of AgNO3, burette reading 1000 by ml of water taken. Okay, that is a gram per liter. When you put the value of equivalent weight of the chlorine, it gives you gram per liter of the chloride content. Then sulphate. Sulphates are generally found in a hard water. Sulphate can be determined gravimetrically, colorimetrically, turbidimetrically. In the oldest method, sulphates in a solution are quantitatively precipitated in a HCl medium and estimated gravimetrically as BaSO4. That is the gravimetric method. Okay, so that is all about the analysis of the water. Some factors are there. Some water pollution laws are also here, but in the semester 4, BSc semester 4 syllabus, only drinking water standards are for the discussion. The rest of the topic are not in the syllabus. So, in drinking water standard, some standards like ICMR, that is the Indian Council of Medical Research, those are important for short question. Give the full form of the following term like that. So, note down that the full form of the ICMR, Indian Council of Medical Research, then the Bureau of the Indian Standards, BIS, Ministry of the Work and Housing, MWH, and the World Health Organization, you already know, that is WHO. Those are the drinking water standards. Okay, like some physico-chemical properties according to WHO, according to Ministry of Work and Housing, MWH, the turbidity in the water is highest desirable value is 5. Maximum permissible is 25 according to WHO, but according to Ministry of Work and Housing it is 2.5 acceptable and cause of rejection is 10. So, that is called drinking water standard. Okay, color, that is 5, 50 according to MWH, 5 and 25. Taste of odor is disagreeable, unobjectionable. pH, that is 7.0 to 8.5, 6.5 to 9.2, that is maximum permissible limit according to MWH, that is 7 to 8.5, and rejection, that is 6.5 to 9.2. So, these are the characters and the drinking water parameters. Okay, you do not have to remember all these drinking water standards, okay, but it is for your knowledge. Sometimes some of the MCQs are from this table may ask, like what will be the permissible or acceptable pH value according to MWH or according to WHO. So, like pH, then magnesium and calcium. So, from this table the important things to remember are pH value, the amount of calcium, the amount of magnesium. Why? Because calcium and magnesium are the main ions for hardness of the water, iron, manganese. So, remember the value of particular those kind of metals like lead, okay, selenium, mercury, PCBs. So, that is drinking water standards. That is all about part 2 of the water sample analysis. If you have any doubt regarding to any topic in this unit, you may ask me in the comment box. Thank you.